Okay, so last time we were looking at confidence intervals using means and t-tests using means. Now we're going to be mostly looking at t-tests with proportions. So we're going to be using question 5 of the truancy dataset. So as you can see here, you're going to create a new variable and call it improved, following the coding scheme this. So the teacher already gives us here the NP-where of what we have to do. So let me just clear my annotations. So I'm just going to go ahead and copy this. Whoa, still annotated. I'm just going to go ahead and copy this to the stats mother load document. Oh yeah, we need to load up data frame because we haven't done that. We did it before, but since I took a break between each of these, I had to reload the data set. So if you give me a second, I will do it. So that gave me an error. Okay, perfect. After some adjustment I had to do, we finally have df-diff because everything was messed up from the fact that I took a break. So I had to reload everything. But essentially, and let's actually cut this out, and I'm going to show you the data frame itself. So here you can see we have ID, grade, gender, your pre-percentage, post-percentage, and your difference. So here the NP-where it's literally telling you if your difference is positive. So if difference is positive, that means that they improved from post-percentage to pre-percentage, or sorry, from pre-percentage to post-percentage. There was actually an improvement, therefore leading to a positive difference. And then we assert that by 1 and 0. So you can see this two ways. You can either see this as did improve and did not improve. So that's kind of how you have to see it. So we're going to say 1 is that improved, and then 0 is that did not improve. This is for our NP-where, so I'm just going to quickly delete this. And I'm sorry if you can't hear much. I'm in a random Starbucks, so yeah. So we have that there. So next up, what we're gonna do is use the function group by. So we're telling group by like separate by gender and improved. So we have two categories of gender, both male and female, and we're looking at how many of each category improved. So once we have that done, so we're gonna run this code, and it's gonna give us a 4x4 table, which is gonna give us from the female gender, 60 did not improve, 92 did improve. From the male gender, 55 did not improve, 92 did improve. And you can actually switch these around, and it gives you pretty much the exact same value. Jesus Christ, that fan is loud. So if you do that, and I accidentally clicked something. Oh, what did I click? Improved. I deleted that. That's what I did. So you can see improved. So did not improve. So 60, 92, 55, 92. It's the same, just in a different manner. But for all intents and purposes of this problem, we're going to look at it the way the teacher gave it to us. So next up, we're going to be using documentation we have not touched. It is called SM. That's models.api. Wow, that's fancy. Yeah. Which is, oh God, that is a horrible arrow, but it's this, that there, this there. My touchpad isn't cooperating. So I don't know what happened here, but it doesn't really matter. Save failed. Hopefully we can resave. I don't know, it probably might be with my internet, but it doesn't matter in any case. I can just add anything we missed. So for this, the problem asks you the number of people that improved per gender. So you're going to do x1. So let's do xn just to have x males. So you're going to see that in the male category, 92 improved. and then X females, you're going to see that also 92 improved. But in order to get our proportions and in order to use the stats models API, we need to actually get the number of n. So this is extremely simple. You're going to do nm, which is our number of males. You're going to add this. So this is 55 plus 92. And then you're going to do nf, which is 60 plus 92. So there you're going to start having your, I'm going to put everything so you guys can see it. F and then NF. So I don't know why that's red, but look, 92, 147, 92, 152. So up to there, we're golden. So this is the formula the teacher is giving us. So as you can see, it is, since we're using proportions, we're going to run a C-test as there are no degrees of freedom needed. We're pretty much just looking at proportion, we're just using C-tests for proportions. So your X1 in this case is going to be XM, and your X2 is going to be XF. And same here, and M and F, and you have that there. So then if you print cstat and p-val, it's going to give you this. So our p-value is very high, actually. So we failed to reject our null hypothesis. So we did not we did not even define it. So I'm just going to take you through what the teacher said. So here again, there's two ways of actually doing this. So you're just testing the proportion of boys to proportion of girls who actually improved. That was our null hypothesis. So there's two ways to do this. You either use iloc, which is very complicated, in my opinion, and you have to use a lot of raw statistics. So here, for example, you need to calculate your own SE using p-pooled and other variables, while with statsmodels.api, you literally just have to do group by and then the variables .size.onStack, you do this here, and then you just use the stats models API, and it gives you your p-value and your C score. So having that already done, I'm just going to show you a couple other exercises where we use raw statistics and not necessarily z-test. Before continuing, because we're going to be looking at this exercise, we're just going to see what exactly the c-tests we can do. So c-test here, you have the difference between two sample proportions. So it's p hat minus p hat 1 minus p hat 2. So you're going to see this whole like mumbo jumbo of things you do not want to use. But so here you have your null and alternative hypothesis. So it's P1 minus P2 for the null, and then you have that that the alternative is different than 0. And for confidence intervals, if this is going to let me scroll, this is not going to let me scroll. That is strange. Why are you not? Okay, what the? I'm very confused. Suddenly I'm in ANOVA. That is fun. So if we go down, 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 let's just make this bigger. And your screen share, stop. Oh, this is stressful. I should have just paused, but anyways, now it's too late. So we're sharing here. Good, it's working now. So if you go down here, you're gonna see this is your confidence interval for two proportions. This is a formula. So you have that is the difference between p hat 1 and p hat 2 times the c times your margin of error. Give me 1 second. So going back here, it is again pretty much the same process. So I'm just going to run you through it. There's no need to actually calculate this. So you have a 98% confidence interval. So that already tells us that our alpha value is going to be 0.02. It tells you that you have 120 large retailers. So that's there. And 85 use regression as a method for forecasting, if this is going to let me annotate. So you have that 85, so that's your XL. So then you have 163 small retailers, which of 78 use regression. So again, you have your NS and your XS, and you can get your sample, your proportion sample, or your sample proportion from that. So again, p hat is just x divided by n. So in this case, you're doing NL XL divided by NL to get p hat L, and then XS divided by NS to get p hat S. So the standard error is when things actually got complicated because you have to add the variances. So you do the square root. So you get your, so you're gonna do this. So you're gonna do NL if, can I actually add text if this is, so you do NL down here, and then you're gonna do p hat L times, and I'm gonna label it q hat L, because remember that q hat is 1 minus. And then we're gonna add the variances here. So it's again, and we're gonna add text. So this is a lot easier for me. You have your NS, and here you have your, up here, you have your p hat. So here you have your p hat S, and then times your q hat S. Q hat S. So that is your standard error. And after that, it's literally the same process. So you have your C star here, that is 1 minus alpha divided by 2 to get the tails. And everything else is pretty much the same. You get your lower bound and your upper bound, and you do, the only thing that changes here is that you have to do the difference between your p hat. And remember, this follows the same order as you did for the standard error. It's just a lot easier. Plus, not only is it easier, that is how you're comparing your sample proportions. And after that, you just get your confidence interval. And here you say we're 98% confident that the difference between the population difference between large retailers and small retailers is between 0.1 and 0.26. Okay, so if that sounds going to be the death of me, I swear to God. So we are looking here at this one. I'm just going to do it a bit differently because here they are using SS norm to calculate the whole thing and ILOC, and in my opinion, it is way too, because I don't know where I was. Sorry, I got distracted by somebody. So here what we're going to see is just a different way to do this. Again, as I said, doing ILOC is way too complicated. There are so many different ways to do it. This is one stage here. So we're trying to look at if the proportion for females without children is different to those without males. So do we have a defined HO? So our HO, and I'm going to define it here, is that your P difference essentially is equal to 0, and that your HA is that your P diff is not equal to 0. So the first thing we're going to see is XF, which is the amount of females without children. So you can see it here. We literally did the group by on stack, learned that by memory. For any HO, you have to be ready for that. So that is our females without children. And for males without children, we put 285. NF, we're going to literally just add the whole female column. I'm pretty sure there's an easier way to do this, but this one's simpler. So you do 11 and then plus 8, and then males, it's literally the exact same thing. 166, and then 1 to 1, 80, 14, and then 10. So once you have that, I already have the p hats pre-made, and you're doing a two-sided proportion C test. So as you can see, we already have XM, XF, NM, NF already added. And this is our p-value. So as you can see, our p-value is pretty high. So it's 0.58. And we do not have an established alpha, but it doesn't really matter. We're just going to assume it's 0.05. And since our p-value is greater than alpha, we're going to fail to reject our hypothesis. And the teacher concluded the same thing. So we failed to reject our null hypothesis. And as you can see, our p-value is exactly the same. Here, you just use SS norm CDF, but frankly, trying to memorize that many formulas is not going to be possible. So just learn this one, the sm.stats proportions C test, and you should be fine. And yeah, that is proportions.